Article 250.122 states that equipment grounding conductors for alternating current systems shall have a cross-sectional area of not less than that in Table 250.122. Article 310.10 states that conductors of different sizes shall not be used in parallel unless approved by the authority having jurisdiction. TC-rated cable is an assembly of insulated conductors with the grounding conductor integrated into the jacket. The grounding conductor is sized according to the current carrying capacity of the cable. Parallel conductors are allowed for current carrying conductors, but not for grounding conductors. According to Article 310.10, parallel grounding conductors must be the same size. The grounding conductor in the TC-rated cable is properly sized for the current carrying capacity of the conductors. Parallel grounding conductors are not allowed, so the conductor from the cable tray should not be used as a grounding conductor. The interpretation of Article 250.122 is incorrect when applied to circuit grounding conductors. This article applies to equipment grounding conductors, not circuit grounding conductors. It is recommended to maintain the existing configuration with the TC-rated cable. It is also recommended to provide a separate grounding conductor of the same size as the TC-rated cable grounding conductor for the drops to the equipment. Install the grounding conductor in the cable tray and connect it to the grounding bus in the panel board. In summary, the request to change the cable is not warranted. The existing installation meets the requirements of the National Electrical Code, with the additional grounding conductor installed as described. The key issue here is understanding the proper application of National Electrical Code articles, specifically regarding grounding conductors and parallel installations, and the distinction between equipment grounding conductors and circuit grounding conductors. The engineer cited Article 250.122, which focuses on equipment grounding conductor size based on the overcurrent protective device in the circuit. However, the situation involves parallel conductors and the grounding within the TC cable assembly. The grounding conductor within the TC cable is sized appropriately for the current carrying capacity of the conductors within that cable. When running parallel conductors, the general rule is that the grounding conductors must also be run in parallel and be of the same size and material. However, the grounding conductor within the TC cable is already providing the required grounding for those conductors. The confusion arises from the potential need for a separate equipment grounding conductor run in parallel with the TC cable. However, since the TC cable already contains a grounding conductor sized for the conductors within, a separate parallel grounding conductor is not required in the cable tray for the main run. However, for the drops to the equipment from the cable tray, a supplemental grounding conductor is needed of equivalent size to that in the TC cable and is to be connected to the equipment and the grounding bus in the panel board. Article 310.10 addresses conductors in parallel, but it primarily focuses on the current carrying conductors. While it mentions that grounding conductors must also be run in parallel and be the same size, this applies more to situations where individual conductors are run in parallel within a conduit, not when a TC cable assembly already contains an appropriately sized grounding conductor. The TC cable manufacturer has already sized the grounding conductor based on the current carrying capacity of the conductors within the cable, adhering to the relevant UL standards and NEC requirements. Therefore, insisting on a larger grounding conductor or a separate parallel grounding conductor for the main run in the cable tray is not justified. The critical point to remember is the purpose of the grounding conductor, which is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. The grounding conductor within the TC cable is already fulfilling this purpose adequately. For the drops to the equipment, a supplemental ground wire is only needed to ensure the equipment is properly grounded because it is not directly connected to the panel through the cable tray, but through a short run of individual conductors. To reiterate, the original installation using the TC cable with its integrated grounding conductor is compliant with the National Electrical Code for the main run in the cable tray. The key is to ensure that the drops to the equipment are also properly grounded with a conductor of equivalent size to the one in the TC cable, connected back to the grounding bus in the panel board. Consider the following points to further clarify this situation. Firstly, the TC cable is a listed and labeled product, meaning it has been tested and certified by a recognized testing laboratory such as UL. The grounding conductor size within the TC cable is part of the listing and is based on the current carrying capacity of the conductors it serves. Secondly, the National Electrical Code allows for the use of listed and labeled products in accordance with that listing. Therefore, using the TC cable with its integrated grounding conductor is acceptable, as long as it is installed per the manufacturer's instructions and within the limitations of its listing. Thirdly, the engineer's interpretation of Article 250.122 may be based on a misunderstanding of the specific application. Article 250.122 applies to equipment grounding conductors, which are used to connect non-current carrying metal parts of equipment to the grounding system. While the grounding conductor within the TC cable does serve as an equipment grounding conductor for the conductors within the cable, it is not necessarily the sole means of equipment grounding for other equipment connected to the circuit. The supplemental grounding conductor for the drops to equipment addresses this concern. Fourthly, the use of parallel conductors does not automatically necessitate upsizing the grounding conductor beyond what is required for the individual conductors. The grounding conductor size is based on the rating of the overcurrent protective device protecting the circuit, as specified in Table 250.122. In this case, the 400 amp breaker is protecting the circuit, and the grounding conductor within the TC cable is sized appropriately for that breaker. Fifthly, it's important to distinguish between the grounding electrode conductor and the equipment grounding conductor. The grounding electrode conductor connects the grounding system to the earth, while the equipment grounding conductor provides a low impedance path for fault current. The grounding conductor within the TC cable serves as an equipment grounding conductor, not a grounding electrode conductor. Sixthly, the local authority having jurisdiction ultimately has the final say on the interpretation and enforcement of the National Electrical Code. If there is a disagreement between the engineer and the installer, it's important to consult with the local electrical inspector to get a definitive ruling. In summary, the existing installation using the TC cable with its integrated grounding conductor is likely compliant with the National Electrical Code, provided that the drops to equipment are properly grounded with a supplemental grounding conductor of equivalent size. The engineer's request to change the cable or add a larger grounding conductor for the entire run is not necessarily warranted. It's important to have a clear understanding of the relevant National Electrical Code articles and to consult with the local authority having jurisdiction if there are any doubts. Let's further break down the relevant NEC articles to ensure a complete understanding. Article 250.4 General Requirements for Grounding and Bonding outlines the general principles for grounding and bonding electrical systems. It emphasizes the importance of creating a low impedance path for fault current to facilitate the operation of overcurrent protective devices. Article 250.45 specifically addresses grounding of alternating current systems and requires that the grounding system be designed to limit the voltage to ground and to facilitate the operation of overcurrent protective devices. Article 250.24 Grounding Service Applied Alternating Current Systems provides requirements for grounding the service entrance. This article is not directly applicable to this situation as it deals with grounding the service, not the branch circuit. Article 250.118 Types of Equipment Grounding Conductors lists the acceptable types of equipment grounding conductors. This article includes conductors within a cable assembly, such as the TC cable used in the installation. Article 300.3 Conductors covers the general requirements for conductors in raceways, cables, and other wiring methods. This article requires that all conductors of a circuit, including the grounding conductor, be installed in the same raceway or cable. This requirement is met by the TC cable, which contains all the necessary conductors within a single assembly. Article 310.10 Conductors in Parallel, as previously mentioned, addresses the requirements for conductors in parallel. This article states that grounding conductors must also be run in parallel and be the same size. However, It's important to note that this requirement applies to situations where individual conductors are run in parallel within a conduit or raceway, not necessarily to TC cable assemblies that already contain an appropriately sized grounding conductor. Table 250.122 Minimum size equipment grounding conductors for alternating current systems provides the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device. This table is often cited in grounding discussions, but it's important to understand its specific application. It applies to equipment grounding conductors, which are used to connect non-current carrying metal parts of equipment to the grounding system. It does not necessarily dictate the size of the grounding conductor within a TC cable assembly, as the conductor is sized based on the current carrying capacity of the conductors within the cable. To summarize, the existing installation using the TC cable with its integrated grounding conductor is likely compliant with the National Electrical Code, provided that the drops to equipment are properly grounded with a supplemental grounding conductor of equivalent size. The engineer's request to change the cable or add a larger grounding conductor for the entire run is not necessarily warranted. It's crucial to have a thorough understanding of the relevant National Electrical Code articles and to consult with the local authority having jurisdiction if there are any uncertainties. Let's delve deeper into the specifics of TC cable and its grounding conductor to provide further clarity. TC cable or tray cable is a multi-conductor cable assembly designed for use in cable trays, raceways, and outdoor locations. It is commonly used in industrial and commercial applications for power, control, and signal circuits. TC cable is typically constructed with stranded copper conductors, insulated with a thermoplastic or thermoset material, and covered with a flame-retardant jacket. The jacket provides protection against moisture, chemicals, and abrasion. TC cable is available in a variety of sizes and configurations, with different numbers of conductors and different conductor sizes. The grounding conductor within the TC cable is typically a bare or insulated copper conductor that is sized according to the current carrying capacity of the conductors within the cable. The grounding conductor is connected to the metal parts of the equipment being served by the cable, providing a low impedance path for fault current. The size of the grounding conductor in TC cable is determined by UL Standard 1277 Electrical Power and Control Tray Cables. This standard specifies the minimum size requirements for grounding conductors based on the ampacity of the circuit conductors. The grounding conductor size is also based on the requirements of the National Electrical Code, specifically Table 250.122. The grounding conductor in TC cable is typically smaller than the insulated conductors, as it is only intended to carry fault current for a short period of time. The insulated conductors are sized to carry the normal load current of the circuit. When TC cable is used in a cable tray, the cable tray itself can also serve as an equipment grounding conductor, provided that it meets the requirements of the National Electrical Code. Article 392.7 Grounding of the NEC allows cable trays to be used as equipment grounding conductors if they are properly installed and meet certain criteria. The cable tray must be continuous and mechanically connected to provide a low impedance path for fault current. The cable tray must also be bonded to the grounding system at regular intervals. In the situation described, the cable tray is being used to support the TC cable, but it is not clear whether it is also being used as an equipment grounding conductor. If the cable tray is not properly grounded, it cannot be relied upon to provide a low impedance path for fault current. In this case, the grounding conductor within the TC cable is the primary means of equipment grounding. As mentioned earlier, for the drops to the equipment from the cable tray, a supplemental grounding conductor should be installed to ensure that the equipment is properly grounded. This supplemental grounding conductor should be sized according to Table 250.122 and connected to the equipment and the grounding bus in the panel board. In conclusion, the existing installation using the TC cable with its integrated grounding conductor is likely compliant with the National Electrical Code, provided that the drops to equipment are properly grounded with a supplemental grounding conductor of equivalent size. The engineer's request to change the cable or add a larger grounding conductor for the entire run is not necessarily warranted. It's important to have a thorough understanding of the relevant National Electrical Code articles and to consult with the local authority having jurisdiction if there are any uncertainties.